Okay, good morning. Welcome to Math Project 100. We've finally made it.
Awesome.
Today we're going to learn about counting in base 16, which is called hexadecimal counting. And we spent a lot of time talking about binary, right?
A lot of time, a week.
And binary is also known as what base?
Base 2.
Base 2. So we learned that counting in base 2 meant you did this. So let's say we had a number like 1, 0, 1, 1, base 2. That meant 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. And so what does that equal?
So 8 plus 2 plus 1. 11.
11. Okay. And we also know that a number like 432 in base 10, which we usually counted, would be 4 times 100 plus 3 times 10 plus 2 times 1. What does that equal?
So 400 plus 30 plus 2 times 1 is 2. 430 and 2.
432, right? But we know that, because that's how we usually think of numbers, right?
Yeah.
Okay. But now we're going to, well, before we go on to hexadecimal, let's do kind of a one that we've never thought of before. How about the number 123 in base 5?
I don't know base 5.
You don't know base 5? Well, it's the same.
It's base 2.
It's the same as the other bases. So this is going to be the ones digit, and this is going to be the what's digit. What's the
5s.
The 5s, and what's this digit going to be?
The 10s.
No.
No. The 20s.
Remember, it went the ones digit, the twos digit, the fours digit, the eights digit. The base 10 went the ones digit, the tens digit, the hundreds digit.
And
so we go powers of the base.
Of 5.
So powers of 5. So first it's 1, then 5, then what's the next power of 5?
5
times 5 is 25. So this means 1 times 25 plus 2 times 5 plus 3 times 1. And what does that equal?
So it's 25 plus 10 plus 3. 25, 10, and 3. What's that? That's it. 38.
38. Very good. Okay. But now we're going to do something in base 16.
Hexadecimal.
Just hexadecimal. So let's first start out with a simple one. How about 94?
In hexadecimal?
In hexadecimal. So this is going to be, this is the ones digit, right? So what's this digit going to be?
The 16s.
Right, so this is going to be 9 times 16 plus 4 times 1. And what's that going to equal?
Well, 10 times 16 is 160 minus 16. 144. And then and 4. 148.
So this is going to equal 148. Okay?
In hexadecimal.
Okay. So that's how you write the number 148 in base 10 in hexadecimal. It's 94. But hexadecimal has an interesting little property that base 2 and base 5 and base 10 don't have. So let me show you what that is. Okay. So let's do our hexadecimal numbers. I'm just going to abbreviate it hex, okay?
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we want to write, we need to be able to write 10, 11, 12, 13, 14, 15. Okay? Because the first digit's going to go up to 15.
Yeah.
Okay, so we write a 1 the same way. We write a 2 the same way.
Not 1.
The same way as 2, 3, 4, 5, 6, 7, 8, 9. But we can't write 10 as 10 because in base 16, what does the number 10 mean?
base 16 at 1, 0.
What does 1, 0 in base 16 mean?
Well, in base 2, it means 2.
In base 2, it means 2 plus 0. So in base 16, what does it mean?
16 and 0.
It means 16 plus 0. So if we're writing in base 16 and we write the number 1, 0, that actually means 16. So we can't write 1, 0, but we don't have any other digits, right? We're out of digits. So we need to do something else. We need some other symbol that's going to mean the number 10.
Yeah.
Okay, so what people know, now you could pick any symbol you wanted. I mean, you could pick
a smiley face.
You could pick a smiley face if you wanted to mean 10. And you could pick, you know, a little picture of a cat to mean 11. And you could pick, I don't know, a cube to mean 12. But that'd start getting a little confusing because you would have to try to remember what smiley face plus cube meant, right?
Yeah.
Then that'd be kind of silly. So instead, to make things really simple, they just start using letters of the alphabet as the standard thing to use. A, B, C, D, E, and F. Okay? So to write the number 15 in hexadecimal, what do you write?
Looks like you write F.
F. And here, why don't you stand up so you can see a little better? To write the number 13 in hexadecimal, what do you?
You use D.
Right, okay, so now in hexadecimal, actually let me make sure, I probably should have put those over a little bit. Okay, so in hexadecimal, instead of having just numbers that are like 13 base 16 or 91 base 16, we also have funny numbers that you've never seen before, like 1C base 16. And what does 1C base 16 mean?
It's the 13? No.
No.
Well, C is 12.
The C is 12, and what does this 1 mean?
16 and 12.
Right, it means 1 times 16 plus 12, and what's that?
28.
28. So the way you write 28 in base 16 is 1C.
Cool.
Cool. Now you want to do a tricky one?
Yeah.
How about the number 3D? 3D. What does 3D in base 16 mean?
Well, it means 3 times 16 plus 13.
3 times 16 plus 13.
What's
Okay.
3 times 16?
Yeah, what is 3 times 16?
48.
3 times 16 is 48.
16.
Plus
61.
plus 13,
Oh, yeah.
which is 61.
Oh, yeah.
Okay, so the number 61 in base 16 is 3D. So when somebody says 3D, maybe they just really mean the number 61.
Is that number as H or D?
HD? No, we don't go up to H.
Why
But-
not?
Well, that would be a higher base.
Oh, yeah.
Yeah, because we remember our letters end at F. But we could have the number BAD base 16.
Bad.
Bad. The number bad. And now what does that mean? It means the D is the 1's digit, the A is the 16's digit, and what's this B represent?
16 times 16.
Okay, do you know what 16 times 16 is?
No. It's a square.
It's 256. Okay? 16 times 16 is
I
256.
think that's a Fibonacci number.
Nope, it's not. Do you know why?
Why?
Because there's only 3 Fibonacci numbers that are perfect squares.
Oh, yeah.
144, 1, and 0. Okay? So bad base 16 means, well, what does B represent?
Well, B is the 256th place.
Yeah, and what number does B represent in our hexadecimal system?
B is 11.
So we have, this number is 11, times 256.
Whoa.
Plus a times 16. Well, what's a?
A is 10.
Okay, so plus 10 times 16 plus...
Well, D is 13.
Okay, so let's see. This will be the last example we do. So can you figure out what 11 times 256 is?
Well, 10 times 256 is 2,560.
10 times 256 is 2,560. And how are we going to figure out what 11 times 256 is?
Just add 256. It's 2,000.
256. Okay.
We'll get 2,000, and then 500 plus 200 is 700. 60 plus 50.
So this is the same as 2,000 plus 700 plus
110.
Plus 110.
Plus 6.
Plus 6. And what's that?
2816.
Okay, so now we have 2,816. That's 11 times 256. Right?
Whoa.
Okay, so now what do we have to add on to 2,816?
13. 2,816 plus 13.
Oh, no. 2,816. What's next? Oh, we had 11 times 256.
Oh, and then 10 times 16, which is 160.
Which is 160. And then what else do we have to add on?
And then 13.
13. Okay.
So that's 2,979. No, 2,989.
2,989. So the number 2,989 in base 10, the number that you would know as 2,989 is bad. Bad. That's a bad number in base 16.
So if someone says bad, they might mean 2,989.
Yeah. So if someone says to you, boy, you've been really bad, they really mean you've been 2,989. What?
What?
What does that mean? I don't even understand. Maybe
That's weird.
I'll give you one homework problem. Let's see if we can figure out another funny word. Oh, I got one.
Cat?
No, because we don't have a T.
Oh, yeah.
Did you figure out one, or do you want me to just come up with one?
Let's come up with one.
I'll just come up with one. Okay. It won't be a word. How about the number? So you just have to figure out what the number 4A3 is in base 16. Okay? 4A3 in base 16. That's your homework problem. Okay?
Yeah.
Alright, do you think you understand base 16?
Yeah.
It's pretty similar to other bases, except what's the funny trick in base 16?
The letters.
The letters, yeah. So once you get above...
You can just use any symbol you want.
You could.
Like a star, a smiley face.
Star, a smiley face. Okay. But so the homework problem is just figure out what number in base 10 4A3 is in base 16. And then tomorrow we'll do adding and subtracting in hexadecimal. Okay? Good job today, huh?
Awesome! Awesome! Awesome!